please welcome Kevin Bloch.
Thanks very much and good afternoon. Thanks a ton for arranging this. Thanks for your time today. Just a couple of things about myself because it's relevant to the presentation. 14 years in R&D in Australia, trying to develop technology here and export it. The next 16 years was with Cisco. I've been as CTO for 8. And the last 4 I've been spending my time looking at IoT, which I'll talk about, and analytics. And I say that as a sort of prelude because you'll see how the presentation meshes a little bit with some of the experience I've had over the last 30 years. Interesting story, I don't know if you know this, last week NASDAQ, in fact right now, NASDAQ is 4% off the peak before the dot-com boom. 4%. It's nearly the highest ever, and it's probably going to surpass that. The question's why, and we want to talk about that. The second thing is half of the top 10 companies by market cap in the US today are technology companies. Pretty interesting. Why is that? And I want to start off with a story. Lewis Hamilton. Anybody know Lewis Hamilton, Formula One? Right? He just won the last Formula One race. But I'm going to take you back now to 2008. And it's Monaco. And can you just turn the volume up a bit? You should have some volume. Even if you don't, it doesn't matter. I can talk through it. So racing a car in Monaco is like sort of driving your bike in your dining room. Okay, it's very tiny, it's very teeny and so on. Now on that, and typically what happens in a race, if something goes wrong, is a bunch of people like this come out and fix the tires. Now, what was really happening in 2008 was it was starting to rain. He was coming second at the time, and it was starting to rain, and normally it takes about 30 seconds for that car to go to the pit stop, tell those people what to do. Obviously, it's all about a race against changing the tires, getting everything right, and so on. He hit the side of the road. He was coming second. That car, this time, has got 200 sensors on it, 200 sensors. And instead of 30 seconds for the instruction to go to the pit stop, what really happened was in 6 seconds, these people, 14 data scientists, 900 kilometers away, had already worked out a few things. Number one, it's starting to rain. They knew exactly where everybody else was on the road. So the instruction to the pit was, you're going to put the not so thick treads. Normally you'd put the thick treads on because it's starting to rain. No, put the half the thick treads because we're going to fully load it up with gas, which again was another question. The reason being that they'd already gathered the data, the analytics. They'd done simulations in the last 12 months on the race course and who else was racing. They knew exactly where every other car was on the road, and they could already tell that if they filled this car up with gas, with these level of treads, he would win the race. He actually ended up winning the race. Why am I telling you this? I'm telling you this because you can't win the race anymore in any industry unless you instrument. And I think that's the key message behind, if we peel back, I would assume most of us here are technical, but when you're dealing with CEOs and senior people who are non-technologists, it's how do we win the race? How do we win this race in terms of the Australian economy, in terms of government, in terms of any industry segment you wish? We can't do it anymore just with the human brain. So I'm just going to rip through a couple of things. One, the way we, Cisco, see the world and the market dynamics, what we mean by IoT, the Internet of Everything. And then I'm going to talk about Australia. What are we doing here? What are we doing here? And I don't just mean Cisco. And how can we, Cisco, help some of you innovate, invest, create, export, commercialize? And that's some of my background in terms of developing technology in this country. We've got some really smart engineers. But the question is, how do we commercialize? And my experience with Cisco really helps inform that. So we see the internet now in the third phase. First phase, early 90s, we got on this new thing called the web, and we had some fun. But then we got serious about social networking. We took it into business and commerce, and that was the second wave, right? And you can see some of the numbers, about a few 100 million things being connected. But now we're in the third phase of the internet. The phase where we're moving from what we call human scale to machine scale. What do I mean by that? Human scale is where everything is really constrained by our brain, what we're thinking and how we control the process. But now as we transition, by the way, we have already transitioned where there are more things being connected than people. We've already crossed that. And we're predicting that by 2020 there's going to be 50 billion things, half of which are going to have an IP address, right? So as we transition, we're going through this sort of inflection point from human scale, where most things were done by our brain, to machine scale, where most things are actually going to be done by computers. Because already, as they say, 65% of all jobs can be done by computers. And I'll explain that a little bit by also bringing together what Cisco means by the Internet of Everything. We've been involved in IoT for maybe 10 years, more at a technical level, protocols, IPv6, new protocol stacks that I'll talk about, etc. But we learned about 3 years ago that this is only valuable in terms of industry segments when you start bringing together the impact on the people and the impact on the process. And if you do, and you can see it there, that's when you get transformative change. So I'm going to take a leaf out of the GE Industrial Internet white paper. At the top you can see a jet engine. You're sitting on a plane. It's now fully instrumented, 200 processors on it, producing lots of data. In fact, 5,000 data points per second, optical fiber, back into a data center in the US, back up to the plane, optimizing the spin in that engine. Closed loop, notice, closed loop, right, in real time, right, because of the huge amounts of data, about 10 terabytes per 30 minutes. That's the amount of data coming off one of these things. Humans can't cope with that. Now, having said that, when that computer down in the data center sees that on engine 3, part number 106 is going to threshold because it's had so much time in the air, it sends a ticket out to Singapore. The plane's going to land in Singapore in the next few hours. It tells a technician there, go to 103, engine 3, change that part. Notice what we're doing. We're going from this closed loop to an open loop where a human is invoked as an exception. Today, that's the rule. Everything's about humans. But we're moving, as I said, to machine scale. No humans. Humans are only involved as the exception. And if you overlay that with what Cisco's saying, you can see how it maps together completely. Thing producing data, changing process, impacting humans. We're seeing a lot of that. Okay, so we are actually in the process of instrumenting the Earth. Everything. Everything you can possibly think. As long as we can put a current on it and we can connect it, we can do something with that thing. And that's what it's all about when we talk about the Internet of Things. But where it becomes really powerful is where GE says, I'm going to present zero downtime or zero unscheduled maintenance. Jeff Immelt, the first thing he'll tell everybody is, my aim as a company is zero unscheduled downtime. How is he going to do that? He's not going to do that with human beings. He's going to be doing that by instrumenting every spinning thing, as he calls it. That's how he's going to do it. So IoE looks something like this. As we drop down, you can see the various components of it, obviously wrapped around security. It's like these things. When we started selling these access points over about 15 years ago, you couldn't talk to, certainly business, about wireless unless you had a very strong security story. Because as soon as you let somebody in there, guess what? You let everybody in. As we move to IoT, we're really expanding that attack vector, so it's a massively important problem. But those are the underpinnings. If you want to put a number on this, and we did this 3 years ago, we put a number on it. We said the value at stake, that is either the profits or the savings to public sector and private sector, is about $19 trillion. I thought that was a big number. Anybody puts a T in front of the thing, you think this is crazy. Harvard, whatever you want. It's a crazy number. Well, here's the thing. 3 years on, we think this is conservative. In fact, McKinsey put a paper out a couple months ago that said by 2025, IoT will present to the world a value of $11 trillion per annum in 2025. So this is kind of conservative in terms of the value that is at stake. And the sweet spot when we bring together, these three things, M2M, P2P, machine to people, is right in the middle. That's the sweet spot where you're starting to get the real potential out of it. And really what you're seeing happening is the relevance and the usefulness is where those four components all come together. Here's a little example in the healthcare industry. A little company called Proteus in the UK developed a piece of silicon you put in a pill. You swallow the pill. You put a little patch on you. The patch, the pill, when the silicon dissolves, chirps to the patch. The patch chirps to your phone. The phone sends a message to your healthcare, your carer. So what? Big deal. Well, here's a real number for you. In the United States alone, one country, because people don't take their medication, it costs the American government $290 billion per annum. That little thing that brings those components together can have very significant impact in terms of the delivery of healthcare, and indeed can not just save money, it can save lives. That's just one little example of that. But in the last, as I said, 4 years, I've been spending a lot of time on IoE. Not talking to CIOs and the IT department, but talking on the factory floor, to the mining companies, in the trucks, in the Pilbara, airlines, in terms of what they're doing, post offices in terms of their business, not their IT operation. And here's the real potential, that the size of the market of the technology that we've been developing the last 3-4 decades is dwarfed by the opportunity as we move it into the operations space, as we bring it together. So where we're taking switches, routers, and sensors and so on and putting it on energy networks, the electricity networks, we're seeing 1, 2, or 3 orders of magnitude more upside than had we just sold it to the IT department. I forgot to mention, in Australia, in Cisco, our sales of IoT we are the second largest country by sales in the world out of 120 countries. We speak for about 63% of IoT sales across Asia in Australia. So already we're sort of pushing the envelope in terms of adoption of IoE in this country. And it's all being driven by this. And I'm not going to get into the detail. You can read the curves. But this exponential world that we're living in is being transformed because we have abundance of IT capability in compute, in storage, and in network capability. And that is leading us to distributed computing. We can put computing everywhere. We can start instrumenting the world and doing some profound things because we're going to collect that data and we're going to use computers to do something smart with it. Dave mentioned that we've been pushing this new concept which we call fog computing. It's not a joke. It's where you take the cloud and you lower it to the earth, right? Why do we do that? Well, if you take a room like this, there's already a lot of compute power in this room. Or if you take, in this case, a little neighborhood, if you go on the road, we're going to instrument that. And they're going to be tens of thousands of sensors. Now, if every more of the world, you're going to see about 40% of the data will never go to the data center, will never go to the cloud. There's 2 good reasons for it. One, you don't need to consume all that bandwidth. It's going to cost you a lot of money. But there's a second, even bigger reason. If you've got an autonomous truck, and there's 900 of them currently operating in Western Australia, there's not a human being on it. Well, that truck is generating a lot of data points, and it can't go all the way to Perth. The latency won't let it. So you've got to do a lot of processing at the edge so that that truck doesn't run off the rails, and the trains and so on. So there are 2 big reasons why we've conceived this thing called fog. And if you look at traditional computer architectures, look something like this, and what we're doing is we're inserting another layer into it, where we're looking at sensing, control, and correlation. You can see why. In the data center, if you've got 10 to the power 2 of things, that's a lot. 10 to the power 3, okay, we can get there. But when we start talking about IoT, and we start putting, multiple processors on everybody's body, when we start putting 200 processors in a jet engine, etc., we're talking orders of magnitude of things. 50 billion things by 2020. If we're going to do that, we need something smart in the middle. And again, you can see the impact on storage and what that means to storage as well. So what Cisco's done over the past few years in terms of its investment is develop an entire system, if you will, which considers the fact that, yes, we're going to have to do stuff in the cloud, but a lot of data is never going to be able to get to the cloud. So we've got to build this entire system to enable that. So that's kind of the summary slide. But I thought I'd give you a better example, and this will lead me into why I'm going to talk about Australia and what we're going to do in Australia. So this teeny little company called N3N, based in Seoul, was in our innovation center in Seoul, and they came up, there's 3 people in this company, came up with a brilliant concept. And the concept, as you can see, it's about video compression. Video compression. So imagine you're now sitting in front of this television. If you try to bring, and there should be sound to this, but it doesn't matter. If you're sitting in front of that screen and you're trying to bring high definition to that one operator, it becomes actually either very, very expensive or you can't do it with high definition. So what this company did was they said, if I want to see, and now this is going off a bit, if I want to just see one of those frames, I don't want to see everything else. Let me stop that. Go back. I don't want to see everything else. What it does at the edge of the network, it says, okay, the operator has sent me a signal. I want to see frame number 103. I'm going to open that up into high definition. I'm going to keep everything else low definition or standard definition, and I'm going to give the operator super clarity of that particular camera. You get it? So if you've got a few hundred cameras out there, they're coming at you in standard def, but when the operator says, I want to see number 103, it comes back to you in high definition. Okay, so that's the way it's working is it's actually sending information to the edge. It's telling the edge, now open up into high def because that's what the operator wants. Okay, that's an example of fog. Now I'm telling you this because that same company, we thought this was such a good idea, we put some money into them. 3 people in Seoul. When we opened, I'll talk about our center in Perth, when we opened the center in Perth, they had 15 customer engagements. And since then, we've now put the product on our GPL, our global price list, sold across 120 countries. This 3-man company based in Seoul. True story. So I'm going to flip through this because Dave's talked about it. We use this a lot, the IoT World Forum architecture, just so you know. You can see the areas that Cisco plays in, and here's the point. We really need Australian companies, Australian research organisations, SMEs, partners, to start jumping on board with us and co-developing. Which brings me, hopefully, to where we are in Australia. What are we doing here about IoT and IoE, and what do we need to do as a country? So back a step, Cisco's investment strategy, innovation strategy is up here. Number 1, we build. So we have 25,000 engineers. We spend about 5.6 billion in terms of our local creation. We buy companies. We bought 182 companies so far, and we'll continue to do that. So very acquisitive, and we complement our technology with it. We partner. Intel's one of our partners, and there are hundreds of technology partners. SAP, for example, are partners of ours. Rockwell, partners of ours. Honeywell, partners of ours. Very important in terms of where we're going. Invest. So we don't just buy companies. We have invested 2.2 billion in 40 funds around the world, which include equity in companies like N3N that I just gave you an example, like Coda. Anybody heard of Coda Wireless? Based in Adelaide. We made an investment 4 years ago. They are the leading provider of vehicle-to-vehicle and vehicle-to-infrastructure. Is that okay? What did I say? Vehicle-to-infrastructure communication. Again, part of our investment strategy. And then the last one, co-develop. Building platforms so that each of you can jump on board and create, be innovative, solve some of the problems that we've got in Australia and go out and export it. So in March at Cisco Live, in front of about 40,000 people, this is what we announced. Venture capital funding, our partner and Bill's here today is Blackbird, where we brought funding, and you guys might say, oh, we're so acquisitive and we make all these, what's the big deal? It's actually a big deal for a multinational to be able to act autonomously in Australia and do our own acquisitions and our own investments. So that was the first part. The second part was to teach people, and we've now got over 100,000 people qualified in writing applications to some of our platforms. Number 3, the Innovation Centre. This is pretty important, and I'll speak about that in a minute. A $20 million investment in Australia in STEM education, where we're all going out as part of Cisco and actually partnered with CSIRO to train kids, to get them excited about science, technology, engineering, and maths. And we're going to do a lot more in that area. And of course, lots of prizes. That one's just closed. So we went around, to the world and said, here's some money to be creative. And obviously, we're actually at the semi-finals of that. So it's closed today, but we'll do more of those. So I talked about the innovation centers. That hasn't come out very well. But that's a map of the world. And down on the right-hand side, you can see Perth, Sydney. And we announced that in March, the 8th Global Cisco IoE Innovation Center. Since then, we opened I think the next slide, we opened the center in Perth, and we're about to make an announcement of an opening in Sydney. In Perth, what we've done and why we're doing this is really to explain to people how IoT or IoE can change mining, how it can change healthcare, how it can transform industry. So that's the first thing. We need partners. We can't do this on our own. We don't make wind turbines. We don't make harvesters. We can't do this on our own. We need people to co-create and innovate with us and to do it on platforms, so you don't have to start from scratch. So example of this, was this sort of triumvirate relationship between a university, that being Curtin, Woodside being the customer with a problem. Their problem is the plant of the future for LNG, trying to get into floating LNG, which requires lights out, lots more intelligence on the platform itself, which requires a hell of a lot more communications all the way back to Perth. So we're working with them on that and ourselves. And you'll see a model around this. This is a kind of innovation center on a slide where we're focused on astronomy because of our involvement in the Square Kilometre Array. Focused on resources, as I said, with Woodside, and because, hey, this is one of the strengths of the country. And finally, in agriculture, because that's another strength of this country. And we believe that, excuse the pun, agriculture is ripe for investment of technology. It's the least vested of all segments in terms of IT. And there's a massive opportunity there. And so you can see that there. And obviously from a Cisco point of view, that should read network, IoT, platform, security, cloud, and analytics. Those are the 4 key areas from Cisco's point of view. So this was the center that we opened up in Perth. As I said, focused around the SKA, Square Kilometre Array. By the way, the Square Kilometre Array is the biggest, I guess you call it, manifestation of IoE known to man. So you've got these antennas that are peering out into outer space, a kilometre of them, producing each little array hundreds of gigabits per second, right? Sending it 700 kilometres via fibre to Perth, supercomputer, the Pawsey data centre, back to that antenna. So remember what I said earlier? Things, producing data, process, people. It's exactly what we're doing. When we turn this thing on, not we, but they turn it on, the first 5 minutes, it'll generate more data than the entire internet ever. And we're doing that in Australia right now. It's all happening right here. So, and as I said, we're going to announce the Sydney one pretty soon. It's pretty cool. We've got a lot behind the curtains. We're really excited about it. And we'd love whoever is involved in development and creation and innovation and wants to have a go where the platform's laid out for you. You'll have people from Cisco helping out. We've got relationships with a bunch of people that we'll be announcing. Come and talk to us. So that's it. There's a huge opportunity in the Internet of Everything. We believe 99% of the world is still unconnected that can be connected. That's our opportunity. I think there's a hell of a lot that we in Australia can do to show the world how to do smart mining, how to do smart agriculture. Thanks very much.